This is Foundations of Math and Pre-Calculus 10. We're looking at Chapter 5.2 and Common Factors. And as I've mentioned, we do three things with many math problems. First is algebra, second is substitution, and third is factoring. We do factoring to help us find the greatest common factor and the lowest common multiple. So that's GCF and LCM. We can factor using prime factorization, factor trees, or other methods. So let's review greatest common factor and lowest common multiple of 60 and 72. So we're going to use a factor tree here. So we're looking for two things that multiply to 60, and 2 works. Now we're looking for things that multiply to 30. We don't need things to multiply by 2 because 2 is prime. So 6 times 5. 5 is also prime, so we don't have to do anything with that. Now we're looking for factors of 6, so that's 2 and 3. So the bottom of the branches, those are our factors. Okay, this is not the bottom, so that's not included. So 2 times 2 times 3 times 5. Here we have 2 times 36, and we have 6 times 6. So again, 2 times 3 and 2 times 3. So we circle the common ones between the two trees, and that's a 2, 2, and a 3. A 2, 2, and a 3. So greatest common factor is 2 times 2 times 3, and that's 12. Now, for the lowest common multiple, we take our greatest common factor, multiply with whatever's remaining. So we have a 5, a 2, and a 3. So we'll just multiply by them in order. So a 2, a 3, and a 5. And we take our greatest common factor and then multiply by the 2, 3, and 5. So the best thing to do is to multiply things that multiply 10 first, so that's 10. And then multiply these two, that's 36. So we have 36 times 10, which is 360. Now, the greatest common factor of polynomials is actually easier than doing numbers. It's the smallest power of each monomial. So, for example, find the greatest common factor of 48 a cubed b squared plus 36 a squared b to the fifth minus 18 a to the fifth b to the fourth, and write it in factored form. We still need to do prime factorization on the constant term. So 48 is 2 times 2 times 2 times 2, that's 16, and then times 3. And we have times A times A times A times B times B. Once you get faster with this, you don't need to do this as repetitive multiplication. 36 a squared b to the fifth equals, so 36 was 2 times 2 times 3 times 3. And we did that in the previous exercise. Times A times A times B times B times B times B times B. Again, you don't have to do this once you get used to it. I'm doing it to illustrate why. And we have 18a to the fifth, b to the fourth. So that's 2 times 3 times 3 times a times a times a times a times a times b times b times b times b. And for polynomials, we're not interested in the lowest common multiple at this stage. We pull off the common factors. And we have to have 1 from each one. And the lowest one is 3. So we have 2 3s, we have a single 3, so we only mark a single 3. And then we have 2 A's. That's our smallest power. And then we have 2 b's. So I'll just take the last ones. Doesn't matter which one you take. So our greatest common factor is 2 times 3 times A times B times B. So that's 6A squared B squared. Now in factored form, this is 6A squared B squared, and we put a bracket. And we write what's left over from the first term, that's 8A. And what's left over in the second term, that's 6B cubed. And what's left over in our third term, that's a 3. And we have A cubed. And we have B squared. And that's all we have to do. So this part is easy. This part is a little bit trickier. So factoring polynomials into binomials. And it's all about seeing patterns. And we are using the distributor property. Let's just do this for constants right now. If we want to simplify this, we do 6 times 12 minus 2 times 12. So this is equal to 72 minus 24. And that's equal to 48. That's just using BEDMAS. But let's use the distributor property. And when we use the distributor property, we don't have to deal with numbers that are quite as big. So 6 minus 2, it's about seeing the pattern. We can pull that out because 5 plus 7 is the same. So now we have 4 times 12, and that's just 48. Okay, let's look at doing this with polynomials. We see a pattern, 3a minus b. So we can take the 6x minus 7y and make that into a binomial. And then we just copy the second binomial. And again, we're looking for patterns. We see this, 4x plus 5y, 4x plus 5y. So we can pull this out as a binomial, 5x plus 3y times 4x plus 5y. Anytime you're not sure of the pattern, you can always try to substitute with just numbers and see if it works on a calculator. Okay, again, this one's a little bit harder, but we need to try to see the patterns. Let's look in the first two, and then we'll look in the second two. So what's common? We want to pull out as big a monomial as possible. So there's a 5 that's common, and there's an x that's common. So we're left with xy, and we're dividing by this number when we're pulling it out. So 10x divided by 5x, that leaves us with 2. X divided by x just cancels out. And what do we want to pull out here? We want to pull out a minus, and then there's a 3 is common here. So minus 3. That leaves us with xy, and negative 6 divided by negative 3 leaves us with 2. And again, we have the patterns as we saw before, x, y plus 2. And this gives us 5x minus 3 and xy plus 2. Now, what happens if you did something like this? Look at this one and this one and this one and this one as your pattern. Well, no problem. We should end up with the same thing. So what's common between this and this? We see a x and a y. Okay, the x and the y are common between these two. So xy, and then we're left with 5x and a negative 3. Okay, so we're pulling an xy out of these two. Let's look at the next terms. We can't pull out any x's. We can pull out a 2. And that leaves us with 5x and a minus 3. And we combine the leading terms. So that's xy plus 2, and we copy the second binomial, 5x minus 3. So these two are still the same. Multiplication is commutative, so we can change the order. So this is exactly the same as 5x minus 3 times xy plus 2. Okay, let's practice with another one. Here we have a 3 and an x. So we're left with x squared plus y. We can pull out a 5, and that's it. And we're left with x squared plus y. So we copy our leading terms. That's 3x plus 5 and x squared plus y. What can we pull out of here? Common factor is 3 and x. So that leaves us with 4x minus 3y. And what's common here is a 7 and a y. There's no x's common. So we divide 28xy by 7y. That leaves us with 4x. Same thing here, negative 21y squared divided by 7y. That leaves us with negative 3y. And then we combine these two terms. We get 3x plus 7y. And we get 4x minus 3y. Let's take a look at a couple of applications. The area of a fishing net is given as 20x squared plus 35x. And we're told that size can be determined by factoring, determine a possible size. So 20x squared plus 35x. So what's common between these two is a 5 and an x. And we're left with 4x. 20x squared divided by 5x is 4x. 35x divided by 5x is just 7. So that's one way to factor it. We don't have to fully factorize because it just says by factoring. So we could pull out a 5, and that would be 4x squared plus 7x. Or we could just pull out an x. That would leave us with 20x plus 35. So there's different ways to factor this. And let's look at one last one. The area of a trapezoid is this. Write this in factored form, and there's only one thing that we can pull out, and that's the h. So we have b1 plus b2 over 2. And we're used to seeing the area of a trapezoid using this formula, not like that. And that completes this lesson.